Hello, everybody, and welcome to the next session. I'm Rich Brown from Berkeley Lab. I'm one of the researchers here involved in the CalFlexHub. And this session is the first project showcase, the first of two. And the idea here is Marianne and Andrew kind of gave the high-level concept and goals of what we're trying to do with CalFlexHub. And now with this session and the next one, we wanted to showcase a few of the projects that CalFlexHub is running to test various technologies and this idea of prices to devices or prices to buildings. And so this particular showcase is focused on residential technologies. And we have 4 great speakers talking about the technologies they're working on. It's a nice diversity. We have 2 researchers, or 2 people from research organizations, 2 practitioners, talking about a mix of space conditioning technologies, pool pumping, and then a more general kind of electrical, whole building electrical type of technology. So as I said, I'm Rich Brown. The first speaker will be Therese Peffer from UC Berkeley. She's the Associate Director of the California Institute for Energy and Environment. And she will be talking about a residential space conditioning technology involving thermostats and ceiling fans. So Therese, do you want to take it away?
Sure. Yeah, happy to be here. I will be describing this CoolFit project. CoolFit stands for its ceiling fan integrated with a thermostat, also integrated with a price signal. So you can go to the next slide. The idea is to, as we all know, California's peak loads are driven by hot days and air conditioning. And so our idea here is to reduce that air conditioning load, which can be in the thousands of watts, with an efficient ceiling fan, which through our measurements, we've measured 8 watts of power. So you can really reduce that load, but still provide thermal comfort, still provide cooling. So ceiling fans provide cooling. They use moving air to cool people through evaporation and convection. We're using a ceiling fan from Big Ass Fans that has an occupancy sensor, a temperature sensor, and so therefore it automatically turns on and off depending on occupancy, and the fan speed automatically increases based on temperature. And so when the temperature starts to rise, you can, we call this 2-stage cooling, where the first stage is to use the ceiling fan. And then as the temperature gets, unbearable and the ceiling fan is not working, to cool you, then you would use the air conditioning. So we really feel that we can reduce quite a bit of air conditioning load through this process. The ceiling fan can be, since it's so low power, it can be powered through a battery. And this is one of the things we're going to be exploring through this project, is to see if we can add a small battery. So when the power outages happen on hot days, we can keep people cool, especially in the hot Central Valley and especially in disadvantaged communities. So the idea here is to reduce costs, to reduce load, but while retaining thermal comfort. We have 2 sites. We have our lab site where we have a fan and an air conditioner set up in the Center for the Built Environment. That's on the UC Berkeley campus. We have a chamber. And then our field site is at the Franco Senior Center in Stockton, California. You can go to the next slide. So I'm joined by 2 colleagues, Dr. Hui Zhang and Mr. Charlie Huizinga, both of the Center for the Built Environment, who are experts in building science and thermal comfort. On the next slide, I'll talk about our progress. So far, we've developed a couple of use cases, both shedding air conditioning load and then looking at shifting the load through pre-cooling. We've developed algorithms. We've integrated with the price signal in the cloud and tested it in the lab. That's that image on the right, where you can see that the set point is changing based on the price. We've selected and visited the units at the field site itself, walked through each unit just to see what it's like and to check out the equipment. We've received the human subjects protocol. We've selected the contractor to install the fans and thermostat and sensors on site, and the fans have been delivered to site. And so the next phase of our project is to go ahead and install the fans and check out the components through the spring. And then in the summer, start to test things when the weather gets hot. We have different orientations for each unit. So the west facing will be, I think, challenging when you have a lot of west glazing facing the sun on the hottest time of the day. And so we're looking forward to just exploring this in the field in the next few months. Thank you.
Okay, thanks, Therese. One thing to note there, you saw that Therese was talking about the field, the tests that they're doing for their system, and it's worth keeping in mind that one of the goals of CalFlexHub is not just to test these technologies in the lab, but really to test them out in real buildings, and starting to get a sense of how these perform in multiple buildings, kind of addressing the scaling up question. So a couple of our later speakers in this showcase will be talking about these collections of homes that we're testing. So the next speaker is Daniel Gerber. He's a scientist at Berkeley Lab, and he'll be talking about more of a whole home electrification technology that he's working on here. So go ahead, Daniel.
Awesome. Thank you very much, Rich. So yeah, I'm doing a project on kind of this field of low power electrification. So kind of just some background on this. We all want to electrify our gas loads. That's the only way that we're going to meet our carbon emission goals. But now consider that you have a gas furnace, gas cooking, gas vehicles, gas water heater. If you electrify all of these loads all at the same time, your 100 amp panel is probably not going to be able to handle it. So you're going to have to get a panel upgrade. And now panel upgrades just for the panel can cost up to $4,000. But if you need to get an electrical service upgrade, you're going to possibly have to pay another $20,000. And so these types of cost barriers are very pernicious to disadvantaged communities, or to anyone really. And for that reason, most people might end up just replacing their gas loads with more gas loads. And so this whole field of low power electrification has kind of been developed in order to attempt to solve this problem. Now, current solutions to low power electrification include replacing gas loads with low power electric loads. But the problem with that is you get less utility out of the load because it's low power. Another solution is the smart panel, where you still have to pay for a panel upgrade, but you can avoid the electrical service upgrade. But the smart panel, it kind of operates by just shutting off circuits. So if you're consuming too much energy for your panel capacity, it just shuts off your water heater, your vehicle, whatever. And so that's also not ideal. We're hoping, as part of CalFlexHub, to have a third solution, which is the use of flexible loads that can curtail themselves when you're about to exceed your feeder's capacity. And so our project is very low TRL, highly, very much a prototype, but we're hoping to demonstrate that if you can tell your loads to curtail, then you can have all of your loads on at the same time, albeit in a curtailed state, and not exceed your electrical service capacity. And so the way we're hoping to do that, as you see by this block diagram, we're kind of planning to have Raspberry Pi in a prototype panel, and that's going to be the brains. It's going to be able to sense the current coming into the panel, talk with the CalFlexHub price server, get a price, and then basically aggregate the price with the current data to tell the loads exactly what to do. Next slide, please. And so we have a very diverse team. We have myself, the electrical engineer, and then Anand is working on the system networking design, and then our intern Kenny is working on the actual control algorithm. Next slide, please. And so far, we're hoping to have this whole thing done in 2 cycles, at least for this prototype demonstration. So far, we've created all of the flexible loads. So we have 2 floodlights, fans, and a space heater. And this is kind of a lab bench scale prototype, but it's just served to demonstrate that this type of solution can actually work. Shown below and in the picture at the very bottom is the panel prototype that we're hoping to use. And that's going to be developed during cycle 2. And this panel prototype is going to have smart breakers, but we're hoping that we don't have to use them. And essentially, it's going to have the Raspberry Pi communicate with all of the smart loads and tell them to curtail before the main breaker within the panel gets tripped. And that's where we are. Thank you very much.
Okay, thank you, Daniel. It's a good overview. And I do see you generated some questions in the chat there. So just everybody remember, there's a session 11:30, the breakout, where you can ask your questions directly. So hold those questions and keep them in mind for that. Our next speaker is Pierre Boll from Olivine. He's a manager there, managing their demand flexibility programs. And he's going to be talking about a technology demonstration using smart thermostats aggregated through the Olivine platform. So take it away, Pierre.
All right, great. Thank you, Rich. Let's see here. Yeah, next slide, please. Yeah, so to start, I'd like to make a few points to help frame the state of the smart thermostat market and industry. And so for context, it's a very commercially available product. Over 20 million households in the US now have a smart thermostat, and about 20%, probably at least 7 million, are Ecobee. Ecobee is a well-established market-leading player in the residential smart thermostat industry. However, most smart thermostat OEMs do not have the capability to respond to dynamic pricing signals. And so the goal and strategy with our demonstration is to really demonstrate the energy, environmental, and financial value that customers will receive through price and greenhouse gas response capabilities. And so that way, technology partners and other OEMs will be compelled to invest in developing the capability and products that they'll need to allow for grid-enabled devices to respond to dynamic signals. And I should also mention here that my team includes myself, Joe Board, Felipe Godinez, and Forrest Suslak as our primary researchers for this demonstration. Next slide, please. And so here's a quick snapshot of what we are doing with our demonstration pilot. We've recruited 20 single-family residences, all of whom have central air conditioning as part of their broader indoor HVAC system. All the participating customers are within PG&E's service territory, and most of them are, of course, in the regions of the state where there's high air conditioning load. These include Fresno, Sacramento region, and the inland East Bay area. Now, some of the key site components include customers having installed and operating the Ecobee smart thermostat. With our demonstration, we're using the Ecobee 3 Lite model. The Ecobee mobile app installed and sort of used by customers. Customers need to have the unique Eco Plus feature enabled on their thermostat, as well as Ecobee providing us access to the runtime, indoor temperature records, and several other key data points that Ecobee control platform provides for us in this pilot. Next slide, please. And so this diagram shows how we are sending the price signals to participating customer smart thermostats. Before I quickly describe what's going on here, I did want to reiterate again that smart thermostat OEMs, really they still don't have that capability to ingest the more dynamic digital price signals to turn them into functional commands. And the challenge that we've seen is really one of an integration challenge and hurdle for the thermostat OEMs. And some of the key components of sort of the integration challenge include determining who and how dynamic price signals will be ingested, who will dispatch the functional commands, as well as finally being able to develop, test, and hone the algorithms necessary to optimize for some of the key components that include, of course, the dynamic price, potentially greenhouse gas signals, as well as, of course, importantly for the OEM and customer indoor climate and comfort. And so this is where Olivine is playing a critical role by initially providing and testing the kind of really key missing component, which is outlined here in the green dotted line box, that will really enable the price to device pathway that we are looking to demonstrate and achieve. Next slide, please. And so finally, I want to show you how our testing and development cycles are being mapped to the outcome that we ultimately want to realize with this project. We have, as you can see here, strategically framed our testing and development work, kind of really using the classic technology innovation framework, going from proof of concept all the way to what we hope will be business adoption. And in our case, what we're really looking to do is make a compelling business case to Ecobee that they can be convinced to build the technology enhancements on their end to enable and encourage the future market adoption to ingest and provide those signals of the dynamic pricing and other, greenhouse gas or other signals that we are testing and demonstrating in the pilot. And as we show here from the proof of concept, what we have completed here in cycle 1 are on the left-hand side, the sort of static 24-hour price curve, and have linked the functional command signal from Olivine's platform to the devices. And as we do move up the sort of chain of complexity here, we'll be measuring key metrics and impacts that include household HVAC load changes, net peak load reduction, estimated customer bill savings, and last but not least, really understand the customer experience and understanding as we run through these various testing periods via interviews and surveys, which will definitely be, I think, really valuable feedback for both the smart thermostat OEMs as well as for the broader CalFlexHub initiative as we think about this in terms of this technology sitting in people's homes. And with that, that concludes my my opening slides. And thank you very much.
Okay, thank you, Pierre. So a couple kind of overarching thoughts that folks hopefully will take away. One is, I think you're starting to get the flavor that there are many different architectures that the CalFlexHub is exploring for how these price signals can actually get out to buildings and be used, varying from kind of directed devices like Marianne talked about and Therese showed, to direct to the building like Daniel was talking about, versus through these kind of cloud-based OEM, original equipment manufacturer platforms. So that's one of the kind of technical challenges, I think you could say, are these variety of signals. And then the other thing, I think Pierre did a good job showing the this kind of progression of CalFlexHub. As these projects progress, we're moving from kind of basic technical feasibility through to trying to establish the ability to scale and the value proposition. So our next speaker is Tristan de Farnville from Skycentrics. He's the CEO of that company. His company is a DER communication specialist, and he's going to be talking about a similar kind of aggregation platform applied to residential pool pumps. So Tristan, go ahead.
Hello, everybody. So next slide, please. Yes, and then that's our contact information, the participants. So that's me and my CTO, Eugene Zook. Next slide, please. So first of all, I want to appreciate what Pierre was doing with thermostats. And as you may know, thermostats have gotten a lot of sex appeal for being available. But when you are in your home, you can actually kind of feel the temperature changes. So pre-cooling helps with that. But variable speed pool pumps are really exciting to support the grid because they can essentially be moved in a much more dynamic way. There's no harm done to the pool pump if you increase its speed or decrease its speed. And then, of course, that uses more power or less power. So it's a very dynamic load, and it can be changed easily. And as Pierre said, the big innovation that we're all doing now at the CalFlexHub is that we're taking schedules typically, or time of use price shapes, which have historically been used a little bit, which are sort of a blunt instrument, and we're changing it to these hour prices that can be much more dynamic, delivered every day, and then allowing these especially flexible loads to say, hey, I can really adapt to this price shape with what's called an action shape. And the question is, where does that action shape translation happen? Obviously, the cloud's very powerful, but the pool pump, eventually the devices might be able to do it. So there's three levels. Are you doing it in the cloud, the translation to the action shape, or the module, or in this case, a CTA 2045 EcoPort module, or the actual pool pump? Next slide, please. So we're doing this with residential homes in California, and you can see the blue price shape. You're going to probably see that a lot. That's a standard TOU price of a peak high price, $1.75, and then the mid-tier price, whereas the orange price shape is that hour dynamic price. So next slide, please. So we've taken that hour dynamic price, and we have not installed the pool pumps yet. We're going to be doing that in January because we were waiting for them to go through UL. This is a new product, this controller that has a CTA 2045 port, EcoPort. But the algorithms inside these smart pool pump controllers is very exciting. So every pool pump has a standard schedule. And typically in California, they're 4 to 8 hours of pumping. But inside the pool pump, if we increase the load with a load up, if we make it use more energy, then it will cut the schedule short to offset that automatically. We don't have to worry about it. So we can dynamically, with these price shapes, change what's happening on the pool pump, and then the pool pump keeps track of its total pumping requirement for the day, which is very exciting. Next slide. Here you see a shed being sent to the pool pump, and then extra time is added to the schedule automatically. So these are the kinds of smart responses that can happen when you have a CTA 2045 module that just delivers a signal, and then the smart device can decide how to change that signal. Next slide, please. So what's exciting is in California, there have been over 100,000 pool pumps with variable speed sold just from one company into the market. And in the past, there have also been these controllers, the version 1 controller that has already been installed in California. And then the version 2 is going to be able to have open ADR and the CTA 2045 EcoPort. So a very flexible controller box that can be brought to California and eventually incentivized and installed in over hundreds of thousands of pools that allow these pools to become a dynamic load, being very responsible and flexible to the grid. And that's, next slide, I think that's it for my presentation. Thank you.
Okay, thanks, Tristan. Okay, so that's the kind of quick overview of these 4 residential projects. Hopefully that gives you a flavor, kind of the breadth of work that's going on and the type of research we're doing. So now we have I think about half an hour here, right, for or 20 minutes for a panel discussion. I have a few questions I'd like to ask our panelists. So I think if we can bring everybody, yeah, that would be good. Bring everybody back into the, okay, and then Pierre. I know Pierre had a couple questions in the Q&A. You may be typing away furiously there, trying to. Okay, hello, Pierre.
Hello.
Okay, okay, so we're all here on the main stage. So I'd like to start off asking about challenges. You know, I think, as I mentioned, these each of these projects, these technologies, we're kind of starting off at this more technology feasibility stage, and we're working towards addressing the questions about scaling and kind of business value proposition. So, you know, given what we know now, what challenges are you facing, and how are you addressing those? So I'm not sure if anybody wants to jump in, or we can go, and maybe Therese, if you want to start off.
Sure. Thanks, Rich. I think, so ideally, we would want our solution to be agnostic to thermostat, right, and agnostic to ceiling fan eventually. So we would put together a package that has the algorithms, the code in the cloud that integrates the price with whatever thermostat, with whatever ceiling fan. And I think that is the essence of the challenge. As Daniel mentioned, I think in his presentation, you know, thermostats, a lot of times products say that they have an open API, and then you dig into it and you find that it's not really open, or that there's other issues. There's the whole works with ecosphere. And I think that every product has a different definition of what really works. And so I think that is a challenge going forward. But I think I think that's something that we can all kind of address. Even everyone on this panel can talk to those issues and how we might look at standards. Like I know Tristan is using a standard and help develop a standard. And I think that those types of things are going to help us with those challenges.
Okay, so just kind of to summarize, it's to make our solutions kind of broadly applicable and not just only working with one vendor or one kind of supply chain. So yeah, that makes sense. Who else wants to? Tristan, I think I saw you eagerly waiting to talk about your challenges.
Oh, no, just agreeing with what Therese was saying. So yeah, I think that open standards are really important. I think it's pretty exciting that the California Energy Commission is looking at a sequence of pool pump controls. Interestingly, then, since pools aren't everywhere, they're looking at water heaters and then EV chargers immediately following. And they've been very interested in the progress of the CTA 2045 EcoPort as something that can help scale and make that dream a reality. They've also been looking at FM radio signals, but most people want two-way communication at the beginning, right? Until we have 1 million devices in the field, it's really important to get the data, make sure they're responding. And so there's a lot of different communication paths that need to happen. And having that sort of USB port for machines, that little eco port, means that at the beginning, as we're developing these markets to scale, which is the big goal, then we're able to choose different communication paths. Sometimes it's worth a cellular communication with that extra cost. Sometimes it's not. And the headaches of Wi-Fi and how people change their router passwords are okay to deal with in some other instances, or an FM radio signal, or a magic future signal. So communications, connectivity has historically been difficult and expensive. It's really getting close to being less expensive, much less expensive. Even cellular is much less expensive, and that's exciting. So open standards and flexible connectivity, I think, is important for the next few years.
Thanks, Tristan. Pierre, you have
Yeah,
any
yeah.
nuances you want-
I definitely agree with Therese and Tristan, with having those open standards and really I think being able to communicate really clearly back to particularly established smart thermostat OEMs, and of course, our case, Ecobee, Google Nest being another, big player that has, some pretty sophisticated features in their products. Sort of what do they need to kind of take that next step to look, at a higher, dynamic responsiveness beyond TOU, for instance, and I kind of look at how CAISO sort of publishes their prices, say in the day ahead, and then of course even real-time market, as we kind of look at those two analogs as something potentially to help kind of map out for these, for instance, smart thermostat OEMs to think about kind of how to ingest and then build the necessary technical components and systems to optimize for them. So I think providing that clear signal through our CalFlexHub is really going to be key.
Thanks. And Daniel, do you want to add anything?
Yeah. So I think the biggest challenge to my project in particular, or my technology, which may also be an issue for other flexible load technologies, but for me, it's mostly a huge regulatory challenge. I'm kind of proposing stuff like putting a lot of loads on the panel. NEC is not going to like that. The local AHJs are not going to like that, and so it's very possible that might be an insurmountable barrier. But I can at least think that if it doesn't work for the panel, we could at least restrict the load flexibility to sub panels or sort of subsystems. So like you can kind of contain the regulatory burden a little bit, modularize it while still kind of having the load flexibility and at least the demonstration that you're hoping to achieve.
Thanks. Yeah, just acronym alert here. So NEC is the National Electrical Code, which is the National Electrical Safety Standard, basically, that governs how electrical panels are designed and installed, and it governs kind of what you're allowed to how much you can connect to a given panel. And then AHJ, Daniel, is authorities having jurisdiction, which are essentially the code certifying of official, the local code officials. Good, thank you. That was a set of responses. So that's that was kind of based on your current experiences. So looking ahead, I think most of you covered a little bit about what's coming up in your projects, but could each of you say a little bit more about kind of where your technology is going, both within CalFlexHub, kind of what your goals are, and then beyond CalFlexHub, kind of where you see the path to market going. So does anyone want to jump in initially on that? Okay, why don't I take Pierre? I'll ask you to go first.
Sure, yeah. So as I had in my presentation, I think within CalFlexHub, we'll look to, test and develop against more increasingly complex dynamic signals, both on the pricing front as well as greenhouse gases. We kind of have 3 to 5 testing periods that were planned out here for 2023. Particularly, of course, want to take advantage of the summer cooling season. Who would have thought when we really got things underway that we'd have one of the chilliest October, November on record, but taking advantage of that weather, at least in the short term, but sort of then preparing for beyond CalFlexHub. I think one thing we're looking to do in kind of that knowledge transfer back end is, think about maybe putting together a type of blueprint that would be kind of really geared within kind of the residential smart thermostat OEM players to really kind of speak their language, to make that compelling business case, and really help map out the technology development, the resources that would be needed to again kind of sell them to take the development in-house and make it a compelling argument in that way. So then that will hopefully get other and the fuller market of residential smart thermostat players to advance their products.
Thanks, Pierre. Let's see, Tristan, do you want to address that kind of next steps and kind of where this is going?
Sure. So we've been really fortunate that in some cases, thermostats, as was discussed by Pierre, have been able to be sold because people wanted mobile app access to it. And so there was a fair amount of development of, oh, there's a lot of thermostats in the field and ecobee and others can control them, Nest. And then of course, Pierre is adding some more price shaped capability to thermostats. But water heaters are a very different beast, and excuse me. So that means that the water heater can, all of a sudden I may have had a Bluetooth deaf, but water heaters are purchased and nobody wants mobile app access to them. So the regulators in Washington and Oregon really helped by making a CTA 2045 EcoPort a standard on water heaters, and California has done that for new construction and is considering it for all water heaters. And frankly, Energy Star and AHRI 1430, which is a national standard, has just joined the bandwagon, literally released yesterday and said, yes, all water heaters will have the EcoPort. So a small regulation in Washington helped the US as a nation be able to move forwards with controllable water heaters. So sometimes a little bit of regulation is really important and can really help when the market has difficulty kind of getting beyond a certain spot.
Thanks, Tristan. Daniel.
Yeah, so as I mentioned, our idea for CalFlexHub is to hopefully create a demonstration that you can use load flexibility to curtail loads before you trip the main breaker in a panel. And so during CalFlexHub, we're just trying to demonstrate this proof of concept, and even this demonstration is going to have its complexities. Like, for example, you might run into latency issues. If you can't control the load fast enough, then the breaker is going to trip before you can tell the load to curtail. And so we're hoping to kind of study all of these issues, hopefully just even iron them out or provide like some solution or some sort of way around it that we can tell people. But ultimately going forward, as I mentioned, this project is very, very low TRL. And so going forward, we're going to have to kind of like ping the industry to see who's interested in adopting it. Like, we'll definitely need some sort of industry champion, possibly Span or Lumen, smart panel companies, or some other companies like Leap is doing a lot of load control and flexibility. But some sort of champion will have to kind of take this concept and then actually bring it to market.
Thank you, Daniel. And Therese, your next steps and kind of vision for where this is going.
Sure. So we're going into the field over the next 6-9 months to really test this product. And, anytime you go into the field, there's always problems, right? Whether it's educating the users and understanding and listening to them. These are seniors. And so understanding how are they able to use the interface, both of the fan and of the thermostat. Sometimes these smart devices have dumb interfaces that are too complicated for the average user to use, especially those who are maybe English as a second language or that are not used to these different new technologies. And so that's a piece of it. It's not just the technology, but the social side of it that we'll be looking at. As I mentioned, we have a unique situation in that we're looking at these very small units that have a lot of glazing and face different orientations. And so west facing, we imagine, is going to be a problem to try to keep people comfortable. And we also know that people are comfortable at different levels. And so just trying to explore that. But in terms of the beyond CalFlexHub, I think we want to put together best practices for what we've done with these technologies in the system, but then we want to look beyond that and look at talking to different fan manufacturers and so forth, and to see really what the business model is and how do we get there? What's the next step? I know when we've talked to Big Ass Fans, they've said, you guys are the only ones asking about a battery to operate these. And we're thinking, really? That's surprising in that when there are power outages on hot days, if you can have at least some kind of cooling for people, that seems like a game changer and really a health and safety issue beyond just power. So we'll be looking at kind of the big picture and what are the next steps for this technology in the future for other fan manufacturers and so forth.
Yeah, that's a good point, Therese, about this connection between demand flexibility and resiliency. Because obviously, we're going to need both in the coming years, and if we have technologies that can provide both, that's great. Stepping back a little, I forgot to mention, I wanted to add a thought about the challenges question that I asked at the beginning. So one of the challenges I know that pretty much all the projects that are doing field work have experienced is the human subjects approval, which for those of you who don't know, that's the process for research of doing informed consent with the humans who are participating in your project to ensure that they're not being, their privacy is upheld, they're not being embarrassed in some way, that they're not disadvantaged by the research. And so, the human subjects, that's a standard research thing, but specifically for this program, the interesting thing is, in doing informed consent, we have to describe what these dynamic price signals are and what the technology is that will be responding to these signals and how it's going to be controlling devices in their home. And, there's a real kind of educational process there, I think. And so looking forward here to the rollout of dynamic pricing, there definitely will be an educational process to help people understand, what does this mean that my prices are not flat kind of monthly prices anymore, or time of use. Now most people are on time of use. I don't just have this kind of off-peak, on-peak periods. What does it mean that it can vary every day? And so it's a very new concept for people. So that's not necessarily, the educational piece isn't necessarily something that CalFlexHub is addressing, but certainly some of the experiences here working with deploying these technologies out in real buildings, I think we'll learn some things about how people perceive these. Let's see, the final topic I wanted to wrap up on is workforce. So part of this deployment is making sure that we have the workforce. Anybody who's tried to do any work in your home with a contractor in the last few years knows there's a shortage of people who are qualified to work on systems in our homes. And introducing this whole new technology about automated reception of price signals and how do you connect these to the right tariff or the right program and install it properly, it's going to be a big issue to the rollout. So one of the not necessarily something that CalFlexHub was working on directly, other than kind of making these technologies easier to use, easier to install. But I wanted to get hear each of the panelists, kind of what's your view of workforce and kind of how your technology, or generally the residential technologies we're working on, kind of interact with the workforce and what we need to develop there. So maybe Tristan, yeah, thanks.
Thanks. Sorry to jump in, but it turns out that sometimes on certain loads, right, there can kind of be self-install features. So the nice thing about a pool pump is the box that gets the signals is a controller that's really easy to install. Other times, you're right? We have to change from a gas water heater to a heat pump water heater. There's 120 volt heat pump water heaters that are coming out. So at that point, we have to wait for an installer. Now, on one hand, that's a really exciting opportunity. On the other hand, there's expenses, there's disadvantaged communities that have less control over it. So it's a mix of sometimes a workforce and a lot of retraining is needed, and that's the big lift that California is facing. But other times it's easier, and so that's what we're exploring. One of the things with CalFlexHub is what can we do that's easy, what can we do that's hard. But it is a big lift to certainly for me, we're trying to get a heat pump system in our house, and choosing contractors that know what to do, that know about the incentives is challenging.
Yeah. Pierre?
Yeah, I can piggyback on that. I mean, with our demonstration pilot, getting the 20 participating customers and literally helping them install their new ecobee thermostat. I'd say only about a quarter of those customers were kind of willing and able to do the DIY installation. But even for a thermostat, it's a pretty intimidating thing to pull an old thermostat out and then of course see some open wires in the wall and then reconnect those to a new thermostat and then put that on the wall. So yeah, I mean, it was interesting for us to look out to vendors currently available that can do this type of installation and check to make sure the product connects to the internet, Wi-Fi and so forth in the home. And kind of as we were looking for vendors, we were kind of seeing, there's certainly some kind of HVAC contracting firms that, specialize in this, but, we're also seeing kind of crossover from like the home security industry, thinking and kind of going beyond just the security systems that they install and, help to manage. And then I think also another big one out there is Best Buy's Geek Squad. That's a really big kind of visible kind of brand that does do this type of kind of in-home service work that we see that as we kind of think about capturing who is doing it currently and so forth.
I think that's really true that the when you think about the kind of smart home industry, it's these technologies are not set it and forget it type of things. They're going to need maintenance and kind of fixing over time, and having an industry that's able to do that is really important. Therese, do you have any thoughts about workforce?
So I just would reiterate what Tristan and Pierre had said, that it's really about the technology. A lot of this stuff is do it yourself with respect to installing a ceiling fan or have someone do it. But I agree, it's the technology that's the issue. What happens when your fan hops off the network and you can't control it with your phone? It's those kinds of things are where we need more training to have people be able to help out with those issues.
Okay. Well, Anna's telling me that we're at time.